Welcome everyone to the lecture on Bayes classification problem in machine learning and pattern classification. Classification is one of the most important tasks in artificial intelligence and machine learning. Among the various classification techniques, the Bayes classifier is a powerful probabilistic approach based on Bayes' theorem, which helps in making decisions under uncertainty. In this lecture, we will discuss the fundamental concept of Bayes' theorem and decision making using Bayes classification. Also, we shall see step-by-step procedure for solving Bayes classification problem in real-world system. Now we shall go into the topic. Bayes classifier. A Bayes classifier is a probabilistic machine learning classifier based on Bayes' theorem. It predicts the class of a data sample by calculating the probability that the sample belongs to each class and selecting the class with the highest probability. Bayes' theorem is given by the probability of occurrence of an event related to any condition or conditional probability. Mathematically, it can be represented by P of A given B equal to P of B given A into P of A by P of B. Bayes' theorem is also known as conditional probability. For a binary classifier, Bayes' theorem states that Qi of x is equal to Fi of x into Pi divided by Z, where Z is represented by F0 of x into P0 plus F1 of x into P1. Z is nothing but the likelihood probability function. Qi of x is the posterior probability, Pi is the prior probability, Fi of x is the probability density function or conditional density function. For a binary classifier, there are only two classes, 0 and 1. So, for a binary classifier, Bayes' theorem can be extended as Bayes classifier, which is given by Qi of x is equal to 0 if Q0 of x is greater than Q1 of x and 1 otherwise. Here, Qi of x is a posterior probability and which can be denoted as probability of class I given x. Such classifier minimizes the probability of error in a classifier problem. There are two types of errors in classification. Classifying class 0 as class 1. This is also called as false positive or type 1 error or false alarm condition. Second type of error is classifying class 1 as class 0. This is also called as false negative or type 2 error or misdetection. So the cost of these two errors may be different in different scenarios. So always there exists a trade-off between these two to minimize the error in a classification problem. Next we shall see about the limitations of the classification problem. Bayes classifier needs knowledge of class condition and prior probabilities which need to be estimated using the training set. So this may not be always feasible. The performance of the Bayes classifier decreases when the features are highly correlated. Also, zero frequency problem may occur for unseen data. Some of the advantages of Bayes classification problem are its simplicity and computationally efficient. It works well with large data sets. It performs effectively in text classification and requires less training data for classification. It can handle probabilistic predictions. Some of the application areas where Bayes classification could be applied are email spam filtering, medical diagnosis, document classification, weather prediction, and pattern recognition. The classifier works in the following steps. Step 1 is to collect the training data, and the data contains the features and corresponding class labels. Step 2 is to calculate the prior and conditional probabilities which gives the probability of occurrence of each class. Step 3. Calculate likelihood probabilities. The probabilities determine the feature values for each class. Step 4 is to apply Bayes' theorem and compute the posterior probability for each class. Step 5, we make a decision on the class depending upon the maximum probability. That is, assign the samples to the class with the highest posterior probability. Using a simple example, we shall see how Bayes classifier is used to classify the attributes of a given data. So in this numerical, we shall see the classification problem. Let me read the numerical. Below is the frequency table for a sample weather data set. Play of golf is the output variable and outlook is the input variable. Outlook has three attributes, namely sunny, overcast and rainy. Play golf has two attributes, namely yes and no. Identify the playing golf in sunny, overcast and rainy belongs to which class. So here playoff is the output variable and outlook is the input variable. This is the frequency table. Sunny following the yes class, the probabilistic value is 3 and sunny in the no class, the probabilistic value is 2. Similarly, overcast for yes class, the probability value is 4 and overcast for no class, the probability value is 0. Rainy for yes class, the probability value is 2 and rainy for no class, the probability value is 3. The total probability of the frequency table is 3 plus 4 plus 2 plus 2 plus 3, which is nothing but 14. The total probability value for yes class is 3 plus 4 plus 2, which is 9. Similarly, the total probability value for no class is 5. So, these values are important when we are calculating the prior and posterior probabilities in the next slides. So, let us see the solution. Step 1, we calculate the prior probabilities. As I have said, the total probability value in the given frequency table is 14. And for a yes class, the total probability value is 9 and no class, the total probability value is 5. So, for yes class, the prior probability is 9 divided by the total probability, which is 14. Similarly, for no class, the total probability is 5 divided by the total probability 14, that is 5 by 14. Since it is a binary classification, we have only two classes 0 and 1. We shall assume that yes falls under class 1 and no falls under class 0. So the prior probability for no class, that is P0, is given by 5 by 14 and the prior probability for class yes, that is P1, it is given by 9 by 14. In step 2, we shall calculate the conditional probability Fi of x for all the three attributes of the input variable overcast. That is for sunny class, overcast and rainy. For sunny, P of sunny given yes, that is F1 of x given yes is equal to 3 divided by 9. That is 3 is the probability value for the sunny yes case and 9 is the total probability values under yes class. Similarly, P of sunny given no, which is equal to F0 of x given no is nothing but 2 divided by 5. 2 is the probability value for sunny under no class and 5 is the total probability of the no class. So, F0 of x given N0 is nothing but 2 by 5. Similarly, for overcast case, P of overcast given yes is nothing but F1 of x given yes is equal to 4 by 9 and P of overcast for no class is equal to F0 of x given no, that is equal to 0 divided by, which is nothing but 0. And for the rainy case, P of rainy given yes is equal to f1 of x divided by s, which is equal to 2 by 9, and P of rainy given no is nothing but f0 of x given no, which is equal to 3 by 5. Now we shall calculate the likelihood probabilities. The likelihood probability is given by Z is equal to f0 of x into p0 plus f1 of x into p1. For sunny, overcast and rainy classes, we shall calculate the likelihood probability Z. Z is equal to f0 of x for 2 by 5 into p1 is 5 by 14 plus f1 of x is 3 by 9 into p1 is 9 by 14, which is equal to 5 by 14. Similarly, for overcast, the probabilistic value for Z is nothing but 4 by 14, and for rainy class, the likelihood ratio Z is nothing but 3 by 5 into 5 by 14 plus 2 by 9 into 9 by 14, which is nothing but 5 by 14. Now that we have determined the prior probabilities, conditional probability and likelihood ratio, we shall now calculate the posterior probabilities. The posterior probabilities for sunny, overcast and rainy classes are as follows. P of S given sunny is equal to 3 by 9 into 9 by 14 divided by 5 by 14, which gives us a value of 3 by 5, which is nothing but 0.6. Similarly, P of no given sunny is equal to 2 by 5 into 5 by 14 divided by 5 by 14, which is nothing but 2 by 5, which gives us a value of 0.4. Similarly, for overcast case, P of S given overcast is equal to 4 by 9 into 9 by 14 divided by 4 by 14, which gives us a value 1. And for the next case, P of no given overcast, the value is 0. For rainy class, P of S given rainy is equal to 2 by 9 into 9 by 14 divided by 5 by 14, which gives a value of 2 by 5, which is equal to 0.4. Probability of no given rainy is equal to 3 by 5 into 5 by 14 divided by 5 by 14, which gives us a value 2 by 5, which is equal to 0.6. Now that we have determined the posterior probabilities, depending upon the posterior probability value, we can assign the class labels. So for assigning the class labels, we have to check the value of Q1 of x and Q0 of x. If the value of Q1 of x is greater than Q0 of x, then the class label falls to one category, which is nothing but yes. Similarly, if Q1 of x is less than Q0 of x, then the class label falls on 0 category, which is nothing but O. So now we shall tabulate the values for our easier understanding. As per the frequency table, there are three input attributes: sunny, overcast and rainy. F1 of x given S is 3 by 9 for sunny class. For overcast it is 4 by 9 and rainy class it is 2 by 9. Similarly, F0 of x given no. For sunny class is 2 by 5, overcast is 0 and rainy is 3 by 5. Z value is summarized as 5 by 14, 4 by 14 and 5 by 14 from the calculations we have made already. Similarly, Q1 of x and Q0 of x from the calculation is being tabulated as 0.6, 1 and 0.4 for sunny, overcast and rainy. And similarly, Q0 of x is 0.4, 0 and 0.6 for sunny, overcast and rainy classes. Now we shall compare the values of Q1 of x and Q0 of x for the three attributes to determine the class of the class label of the particular attribute. For the sunny class, Q1 of x is 0.6 and Q0 of x is 0.4. So obviously it is understood that Q1 of x is greater than Q0 of x. So it falls under class 1, which is nothing but S class. And for the overcast case, Q1 of x is 1 and Q0 of x is 0. So here also it is evident that Q1 of x is greater than Q0 of x and the class falls under one class which is nothing but S. And for the last category, that is rainy, Q1 of X is 0.4 and Q0 of X is 0.6. So here it is observed that Q1 of X is less than Q0 of X. So obviously the class falls under 0 category, which is nothing but the no class. So thus, using Bayes' theorem, based on the posterior probability values, the maximum of the posterior probability is being assigned to a particular class label. Hope you all who have understood the session on Bayes classifier using this simple example, how classification is performed using Bayes classifier. Hope you have enjoyed the session. Thank you.